Limiting reagent is what this stuff is called. And it's very applicable because it doesn't matter what you're trying to make, what chemical, what the process is, something's always going to get reacted up first. You can't stop it because there's no way you can have all these reactants and at the molecular level have the exact right number of each one of them. It's never going to happen. There's always going to be something left. Something's going to react first. And when that something is all used up, everything stops. You're not going to make any more product. You're not going to, right? It's done. And that's all we're really messing with, is finding out what reacts first and using that to figure out the amount of product you're going to have. That's really all we're going to do. So let's see how to do this. This might be a northern thing, but I don't think so. I think you guys have made s'mores before, right? So this is how I like to make them. I'll take 2 graham crackers, 9 marshmallows, an entire chocolate bar. And then in the end, I'll break it in half so that way I guess I don't pig out too much. So we'll make 2 s'mores out of it. Now this is all that was brought. 18 grams, 90 marshmallows, 7 chocolate bars. So in theory, how many s'mores can be made? So, I don't know. Kelly, how would you approach a problem like this? How many s'mores could theoretically be made? Anybody have a suggestion? 7? 7? I mean, even if you figure out an answer, look at the next question. You got 90 marshmallows. You got to figure out how many s'mores you can make from that one. And then you got to do the same thing for the chocolate, right? Wouldn't you have to? You get an answer for every one of those. And then what would be your true answer? The smallest one. Exactly. Now, if you're not so sure how to get an answer for like the 18 grams, well, that's all we're going to do today. Let the units tell you what to do. We have a funky looking mole bridge. It's 9 marshmallows to 2 grams to a chocolate bar to 2 s'mores, right? But it's the same thing. Start with 18 grams. And I like to put my units on the end here of what I'm after because then it really guides you. S'mores. Now there's no converting to moles. We're ready to use the mole bridge right now. It's kind of weird to call it Monica Lopez a mole bridge, but what ratio do you put in there to convert to s'mores? Two s'mores. Now the 2 s'mores are going to go on the top or the bottom? The top, because you want to end up. You want to end up in that. Good. Keep going. What do you put on the bottom? The 2 grams. Exactly. See where she got it? Mole bridge. I guess we're done, right? Because the grams are done. We're in s'mores. There's nothing else to multiply by. We'll just screw it up if we keep going. So the answer would be 18. Now you got to do it for the marshmallows. Jared, what would be my mole bridge ratio for marshmallows? You want to see it? 2 s'mores for every 9 marshmallows. All right, so the marsh cancel. What? 90 divided by 9 should be 10. Times 2, you get 20. And now I need these 7 chocolate bars. April. 2 s'mores for every 1 chocolate bar. So 2 times 7, 14. So I guess to answer this question, Aaron, theoretically, how many s'mores can be made? You'd say, what's that? Right here. How many s'mores could be made? 14. Pick your smallest answer. There's not enough. If you pick anything else, there's not enough chocolate bars. Exactly. That's the whole point. If you pick anything else, there's not enough chocolate bars to do it. You can't do it. That is the whole point. Perfect. Okay, but now we need to get it into some terminology here. What is the limiting reagent? Paul, what's another word for reagent? I don't think we use the word reagent. Reactant. I wish they would call it reactant. It would make a lot more sense. So let's let you answer that one, Paul. What would be the limiting reactant or reagent? What would it be? It would be the chocolate bars. That's what they're referring to when they say limiting reagent. It's whatever got used up first. The chocolate bars. Okay? So that's a limiting reagent. Theoretically, I changed a few things in here, but than what you have. Get some space. Theoretically, how many extra marshmallows are there? Theoretically, how many extra marshmallows are there? So the chocolate bars all got reacted up first. That means everything else, there's something left over. The question is how many marshmallows are left over? How would you figure this out? Oh, we could. We could start with the 14 s'mores and figure how many marshmallows were used up, and that will work. But it's really more work. It's more steps, I think. Maybe not. But I think it'll make more sense if we approach this the same way we approach the problems that are coming up with moles and actual chemical reactants and products. For all these funky, weird questions, how many extra of this? How much of this is left over? Always use the limiting reagent. Use him to answer all questions. So you would, in this case, you'd be using the 7 chocolate bars. Use the limiting reagent to answer all these funky, weird questions. So if we use the 7 chocolate bars, is my guiding hint here. Let's convert that limiting reagent into what? Convert it into marshmallows. Now, if you do that, is that your answer? This is the 7 chocolate bars that were used up. No, this is the marshmallows that were used up. So then, subtract it from, there it is, 90, exactly. That's the game plan. Use a limiting reagent for all these weird questions. So convert 7 chocolate bars were used up. So that means, I don't know, we got to figure it out. We have, what was it? 1 chocolate bar for every 9 marshmallows. So, oh, we're done. So, right, because they cancel. 9 times 7 is 63. So left over, how'd I get 1 chocolate bar? Do you see where I got it? Okay. No, I was going faster. So 63. What's 90 minus 63?
27.
Oh, thank you very much. So left over is going to, well, number left over would be 90, whatever you had, minus 63, and you said it's 27. Okay. So I just use the limiting reagent for all questions, really. Okay. What is the theoretical yield of s'mores produced? What would you guess they're driving after? Caroline, what would you guess they're driving after? What is the theoretical yield of s'mores produced? Probably what? Probably the 14. That's what they're after. In theory, how much of the stuff can you make? Well, you use a limiting reagent to get it, and we already did it upstairs, up here. We don't have to do it again. But if we wanted to, we could convert the 7 chocolate bars into s'mores. Use the limiting reagent for everything. So the answer's 14. She's right. If 7 were actually made, what is the percent yield? Now to get percent, here's our equation. Divide the actual by the theoretical. Multiply by 100. So we'd have the actual they said was 7. There's no way you know what the actual is. They have to tell you, right? Someone probably ate some chocolate bars or something. I don't know. Or they dropped them on the ground. I don't know. Something broke. They only got 7 made. Theoretically, they should have got 14. You brought enough stuff for 14. So 50% is a theoretical yield. It's always the actual over the theoretical. Okay. So before we go and jump into these questions, just realize it's the exact same game plan. You take everything they gave you, right, and convert it to product. And then you pick your what answer? The smallest one. And whatever gave you the smallest answer, that reactant is called the limiting reagent. So it's not so bad. And your smallest answer, what is it called? Theoretical yield. All right, let's give it a shot. We've got 4 moles of ammonia reacting with 5 moles of oxygen, giving us 4 moles of nitrous oxide and 6 moles of water. Okay, in the above reaction, 24.2 grams of ammonia is combined with 32.6 grams of oxygen. Determine the limiting reagent and theoretical yield in grams for the production of water. Okay. So Monica Soto Ruiz, how are you going to set this up? What are you going to do? All right. We need to convert what to what? Yeah. Grams to moles, but we want to end up, hey, maybe let's start with where we want to end up. Where do you want to end up? Grams of H2O. The more detail you write, the easier the question's going to be, right? Now, where do you have to start? NH3, how much of it? 24.2. Then you got to do it all again for the oxygen, right? We don't have any choice. I mean, I guess you could guess, right? What's the limiting reagent? It has to be a reactant. It has to be either this one or that one. And you could guess. And you might want to guess this one, I guess. If you have like 2 seconds on the quiz, probably guess him because he's a smaller amount. But realize what messes everything up is, dang, the molar masses are different for those guys. The mole-bridge ratios are different. I mean, you have to go through all this work. It's not always going to be the smallest one. Okay. Plus, they want to know theoretical yield anyway. Okay, so let's try one of these here. Jasmine, what's going to be your first step here? What would you do? What's that? Yeah, the mole of NH3 on the top. Oh, not 4, because we can't, I think she said 4, right? We can't use the mole bridge yet because we're not in moles. So we got to get it to moles, so that's 1 mole, molar mass, right? It's that molar mass thing. We need a nitrogen and 4, not 4 hydrogens, 3 hydrogens. Nitrogen is about 14. Every hydrogen's 1, so 14 plus 3, 17. And write out all the units. It'll help you. Now we're ready, Eric, for the mole bridge. You put in what?
6 moles of H2O over 4 moles in H3.
There he goes.
3 and
4 moles NH3. Right? Let's see if you're following. Talia, what if I totally quit right now? Right? What would be the units of my answer? The H2O, the moles of H2O. You got to keep going. Exactly. All over 16 and 2 hydrogens. That would be... Oh! Alyssa, thank you. All right? Otherwise, they don't cancel. Thank you. 18. 8, yeah, because oxygen 16, 2 hydrogens would make it 18. 18 Gs of H2O. All right? Now notice how, and remember molar mass, it's always a 1 there. Always, always, always. That's how molar mass always works. Look here too, it's always a 1. All right, so anything on top multiply, anything on bottom divide by. So 24.2 divide by 17 times 6 divide by 4 times 18. I get about 38.4 is what I got. Okay. You do the same thing for the oxygen. .6 grams of oxygen. Jesus, what should we do first here? Moles of the oxygen. So you'd write what? 1 mole of O2 on top and 32 Gs of O2 on the bottom. He just looked up the molar mass of oxygen is all. And keep going, Priscilla. Five moles of oxygen on the bottom. Yeah, there it is. The 6. Yeah, that mole bridge. Gotta keep going. Now it's going to be the same as the last step, right? We need the molar mass of water again. And a mole of water, 18 grams of water. So 32.6 divided by 32 times 6 divided by 5 times 18, about 22. Man, I would have guessed wrong. I would have guessed the ammonia was the limiting reagent, right? Anyway, Alyssa, we're supposed to determine the limiting reagent. So what is the limiting reagent now? It's the O2, right? Limiting reagent, you have to pick a reactant. It's the one that gave you the smallest answer, so it's going to be the O2. Where can we write that, I guess? Limiting reagent is O2. Nice big box around it, right? Then they want to know what's the theoretical yield in grams for the production of water. So Summer, what would you say for that? The 22. That is the theoretical yield. It's the smallest answer. Theoretical yield, right? Limiting reagent. Right? Make sense? If the actual yield is 18 grams of water, find the percent yield. So it looks like, unless it's on top of the quiz, you're going to have to know what that equation is. How do you get percent yield again? Actual over theoretical times 100. Actual, and they have to tell you that one, over theoretical times 100. Now that's just going to be 82%. Okay.
With the actual yields, is it always just going to be like a percent like that, or do you have to see the tens?
Oh no, they don't. Look, they don't even. Isn't that an odd thing? Eric's wondering about sig figs. It's really odd if I'm following the book. If they make a really big stink about sig figs, you'd think they'd stick to it, right? This whole time, but they don't. So if I'm following the book's not worried about sig figs, I'm not worried about sig figs either. So just give your answer to 2-3 digits and you're done.
What they give you usually, right? Like if they give
Yeah, usually you follow that. If they give you in 3 digits, you give it in 3 digits. So I wouldn't really worry about sig figs too much. Okay. Let's try this one. Kelly, we've got 30 grams of carbon disulfide and 35 grams of oxygen reacts. And they give us a reaction. Which reactant remains unconsumed at the end of the reaction? What are they looking for, really? Which one comes out less? Now, which one is, when you say one, which one are you talking about? Either CS2 or O2 remains unconsumed. Are they talking about the limiting reagent? Or the other dude? It's the other dude, right? The one that remains unconsumed. That means there's stuff left. So, pretty much, find the limiting reagent, 'cause that's the only one we know how to find, and then pick the other one. That's the only game plan I have, is because they want to know which reactant remains unconsumed. It's just the opposite of limiting reagent. Does that make sense? Monica Lopez, make sense?
Does it matter which mole rate you use?
Good question. Does it matter?
It should work either way.
Should it work either way? That's all the questions I want to ask. That's good. Should it work either way? We want to pick, like Eric's question and my question, just took it right out of my mouth. Let's pick CO2 and find out the limiting reagent. Let's pick SO2, find out the limiting reagent. Does it matter, Monica? Yeah, does it matter if we picked, I don't know, CO2? You know, because we're trying to figure out the limiting reagent. So I guess we would start with the 30 grams of CS2, the 35 grams of oxygen, convert to CO2. Or do the whole question again, converting to SO2. Would you get the same limiting reagent? You know, because then you pick your smallest answer, and whichever one gave you the smallest answer, that's your limiting reagent. It doesn't matter. Right. It doesn't matter. Just pick one. I don't care. It doesn't matter. You'll get this. You can end up with the same limiting reagent. So, I don't know. Just so April, so we're all doing the same thing. What product should we pick? CO2? Is that what you said? Product. Pick a product. Either CO2 or SO2. Doesn't matter. CO2. Okay. Let's go to CO2. Oh, hey, here's something. Do we have to go all the way to grams of CO2 to figure this out? Or could we stop at moles? We could stop at moles. Because you're picking your smallest answer, right? We could actually stop at moles. And you don't have to, but you could stop at moles of CO2. And whatever your smallest answer is, go back. Oh, that guy's my limiting reagent. Okay. Well, you would, for example, if you, well, let's back up. What I'm saying is you could just leave this step out. Right? So if I just left him out, I'm in moles of water. I mean, you can do the last step if you want and convert to grams of CO2, but you don't have to. You get the same limiting reagent if you just stop at moles. Because we're just going to pick our smallest answer and go back and see, oh, he's the limiting reagent. Okay. So try it. See which one remains unconsumed. Yeah, but they're talking about reactants, so it's right. So you can't save any time. You can't save any time. So try it. Pick a product, and you can convert to grams of that product or moles of that product, but just do it the same way for both reactants, the 30 grams of CS2 and the 35 grams of oxygen. Otherwise, you can't compare. You can't pick the smallest number. And if you're not sure where to start, just ask. Yeah, good. One of those for every 3 of those. Oh, I see. You're getting into molar mass first, right? 32 grams. All right, because 16 and 16, 32 grams of oxygen. So you got to get into moles first. So that molar mass of CS2. Yeah, good. Now keep. Oh, but the grams. They started out with grams of CS2. This is 30 grams of CS2, so the grams has to be on the bottom. Yeah, then you could just quit here and end up in moles of CO2. Do the same thing for this one. Yeah, keep going. Now, this one, you have to add up a carbon and 2 sulfurs to get this number. So I don't think it's 30, but it's something. Okay, now you got to do the exact same thing for this one, for the oxygen. All right. Oh, you got to keep going. You need the mole bridge. So, where's oxygen? Yeah, so you'd have 3 moles of oxygen for every, are we going for carbon dioxide? Well, oxygen has to be on the bottom though, right? Because it's mole O2. So 3 moles of O2 for every 1 mole of CO2. And then you get to stop there. You do the same thing for, like you're doing, the same thing for the carbon disulfide. Did anyone figure out which reactant remains unconsumed? Which one is it? CS2? So that means O2 must be your limiting reagent. Does everybody agree? All right, CS2. I guess you could say because O2 is the LR. Right? No problem getting part A? Part B, how many grams remain? I just changed your question a little bit from your notes there. How many grams remain of each reactant? Huh? How many grams remain of each reactant? Well, how many grams of oxygen remain? It's the limiting reagent. 0, exactly. So that one's easy. 0 grams of oxygen. But the carbon disulfide, that's a different story. That one we're going to have to figure out. And to figure out these questions, always use the limiting reagent. Okay. Always use the limiting reagent to figure out these questions. So, limiting reagent we said was oxygen. So here it is right here. Use it to answer all these weird questions. Convert it to what? Convert it to what? The CS2. And that'll be the grams of CS2 that, what? That were used up. So you better get an answer less than what, or you know something's wrong. Less than 30. Because you have 30. If you go through converting 35 grams of oxygen all the way to grams of CS2, and you get a number bigger than 30, something's messed up. It has to be less than 30. Because O2 is a limiting reagent. He gets reacted up first. You're going to get something less than 30. You can get 27, 25, I'm not sure. But that'll be the grams of CS2 that reacted, because 35 grams of O2 reacted. So just subtract whatever you get from the 30, right? Whatever you get here, subtract it from 30, and that'll be the stuff that remains. Okay, so try it. Convert that limiting reagent into what we're interested in. We're interested in seeing how much of the other reactant is left, so convert it into grams of CS2. Now you got 33 and 48. Yeah. Yeah. For part A, did we mess up somewhere? Yeah. Are you guys sure, according to Monica's here, are you guys sure CS oxygen's a limiting reagent? She got a smaller answer for CS2. Everyone got a smaller answer for O2? Where did you? Let's see where she messed up. 0.365 for O2 and 0.39 for 1 mole. What's your molar mass of? Oh, it's your molar mass of CS2 is wrong. Because Alyssa got 76. So you had a carbon and 2 sulfurs. You get 76. Because the carbon is 12. And then each sulfur is 32. Yeah, you get 6. Yeah. Yeah, there it is. There it is. So, okay, so you converted this to that. Okay, now he's the amount that reacted. Because 35 grams of this reacted, so that amount reacted. Subtract it from 30. So whatever you get here, subtract it from 30, and you'll have your answer. Right? Did anyone get an answer for grams of carbon disulfide? About 27.8 or so. Depends on your rounding it. You know, 27.8, 27.7, really close to that. And then they want the amount that remains, so because that's the amount that reacted. Because this reacted. So subtract it from 30. So the CS2 remaining, 30 minus 27.8. And that's what, 2.2? Okay, so somewhere around there. Yeah. Oh, because oxygen's 32.
That's right. I should have recognized that because it's double.
Yeah.
I need to divide by 2 to get to the 27.8.
Yeah, because oxygen's going to be 32. Okay. So there's another one up here if you want to practice again, but I think you got the idea. All right. We're going to in these limiting reagent questions, just list out, right, kind of like we did something like here. List out all the reactions, convert it to some product, and whatever gives you the smallest answer, that's a limiting reagent. And you use a limiting reagent to answer all questions. How much of this did I get? How much of this is left over? How much of this reacted? It doesn't matter what the question is. Always use a limiting reagent. And just convert from one set of units to whatever units you're interested in. Okay? So let's get the exams out, and you can pick those up, and we'll see you in lab. come by and ask some questions on this if you're not sure. No, in lab, all we're going to do this week is retake the exam.